Hello. Okay, so welcome to part 2 of our partial fraction shortcut tricks. Okay, in our part 1 we introduced the concepts and the foundation to partial fractions and how to know the number of fractions to be formed, the nature of the numerator to be established before solving the problem. That's what we did in our part 1. So you can check the part 2 part 2. So we have here an objective question before us, and then we have the resolve this problem into partial fractions, and then we have the options given to us here. And the essence of this is to enable us work out our problem very fast when it comes to objective exams question. Like I earlier said, when it has to do with objective exams, you don't need to stress ourselves going through the rigorous process of solving partial fraction. Of course, if you know how to solve partial fraction, you can agree with me that to solve this very problem. So, but with these shortcuts, you are covered, within a short period of time. Okay, so now if you follow up my first step of the class, my first part 1 of the video, you agree with me that without solving this problem, okay, the answer to this very partial fraction problem lies between option B and C. And why did I use the word lies between option B and C? And you can clearly see that in option A, we are having x plus 3 here and x minus 4 here. And we've also established that in our partial fraction, the denominator does not change. As a factor, the denominator does not change whatsoever. Okay? Now, but we're having here x plus 3. That means that this is actually a no for us. Okay, so we strike at that very well. Okay? Now, look at the second one. X minus 3, x minus 4. So, it's in line for now. Now, x minus 3, x minus 4 is in line for now. Okay? So, now, we'll look at option D. In option D, we have 2x plus 3 and x minus 4. So because of this 2x plus 3, then this is a no for us. So now we are now going to choose between B and C. So how do we go about getting B and C? How do we go about knowing the correct answer between B and C? So, alright, so if you watch now, I've strike out A and D. So we have these two men to judge between. Alright, between B and C, which is the correct answer to this very problem. Alright, so let's go. Now, the short code we use here, the test value, the test code, I don't know how you call it, okay, you use here is usually 0 and 1, okay, as in the number you use in place of x here is usually 0 and 1. Now, why do we choose 0 and 1? 0 and 1 is to work with 0 is very, very easy to work with 0 and 1. Remember that any number you multiply by 0, it is 0. Any number you multiply by 1, it is that number. So without using calculator, without stress, it is very easy to work with 0 and 1. But there is limitation in using 0 and 1. Now you can use any number, alright? But like I said, to use 0 and 1 is very easy, okay? Now, but there are cases where you cannot use 0 and 1. Yes, there are cases where you cannot use 0 and 1. In that case, you can try -1 or 2 or 3, as the case may be. That in the case where this 3 here, let's assume this 3 here is 1. If this 3 here is 1, I cannot use 1. Because if I say 1 minus 1, I'm going to get 0. And anything divided by 0, that will give you undefined. That means it makes the function undefined. That is a math error in your calculator. Alright, you know what I mean? So now, the same way also, if let's assume that there was no 3 here, I'm just having x into x minus 4. Yes, there could be a question of that form. I cannot use 0 because that x represents 0. Like if I'm using x to be 0, okay, then if I multiply out, I'm still going to get 0, which is this over 0. That will give me undefined fraction. So I can't use that. So the choice of using the choice of the number, the test code or the test value you use is being affected by the denominator. So please let's get that very quickly. But in the case of this, in the problem of this form, I'm going to use 0 because 0 is usually the very fastest way to get your answer in this shortcut. Okay, so let's go. So what we do is that we are going to replace. We are going to, anywhere we see x, we are going to put 0. Alright, in the original question first. So we are going to have here, okay, as if you put 0 in place of that, 7 times 0 gives 0. So we have minus 25 left. Then 0 here, if you put 0, you are going to get minus 3. If you put 0, you are going to get minus 4. Now open the bracket, you are going to get minus 25 over what? 12. So minus 25 over 12 is the result we get in the original fraction or function given to us. Okay, so let's do the same thing in the options. Anyone that give us the same answer becomes the correct answer. So let's see in B and C. So we have here in B minus 5 all over, I put here you have minus 3 plus 6 all over, I put 0 you have a minus 4. That will give us 5 over 3 minus 6 over 4. Now by the time you add up, this will give us 12. The LCM is 12. 12 divided by 3 will give us a 4. 4 times this will give us a 20. 12 divided by 4 will give us 3. 3 times this will give us a 18. So we have 2 all over 12, which is equal to 1 over 6. That's what we have there. So we have a 1 over 6. Y here is what? Minus 25 over 12. That means that B is not our answer. So, but let's see C first. Let's see. Now in C, we are going to have 4 here minus 3 here, then plus 3 here minus 4 here. Alright, so we end up having minus 4 over 3 minus 3 over what? Over 4. Over 4. As usual, we'll take LCM. The LCM is what? 12. So 12 divided by 3 will give us 4. Times this we have a 16. Minus 12 divided by 4 will give us 3 times this. We have what? Minus 9. So we have minus 25 all over 12. Good guys. So we see that at the end of the day, option C is the correct answer, because when we put 0 here, we got this. And we see put 0, we got this. And like I said, you can check any other number. You can check 1. You can check 2, you can check 3. But 0 and 1 are usually the smartest number to use in these shortcuts. So let's see another example. Meanwhile, I will also give you a question to solve, and you can drop the answer in the comment section. Let's see. Now, if you have followed up my first class, okay, and the concept I've already established, you notice that without solving this problem, okay, I can easily get my result. But before I do that, there's a challenge here. Can you check what do you observe? What do you observe in the question given to us? If you actually follow my part 1, part 2 of this video, then you follow up that, you understand that this has not been factorized. So you have to factorize this. Alright? Now, if you factorize this, following your long division factorization, and the rest of them, we are going to get this to be 8x minus 8 all over. This will give you x into x minus 4, then x plus 2. Okay, you can check out other of my videos about factorization, okay, where I explain how to factorize polynomial functions, okay. But for the sake of this video, we are just here to look at the shortcuts on how to get this done, okay. So now, if you factorize it, this is what you are going to get. And of course, the degree here is 3, so you are going to expect to get 3 factors, okay. So because the reason why you must do that is that if you have a function like this, you cannot actually get the partial fraction without you factorizing it. That's just what I explained in my part 1 of the video of this shortcut trick. So with this now, with these factors now, without solving this problem, I can easily go for my answer. So what do we do? As we did in the first example, look at this factor must also exist in our partial fractions. So here we have x, here we have x minus 4, here we have x minus 2 instead of x plus 2. So I'll write this off. Are we there now? Now, in the B part, I have here x plus 4, x plus 2. But here is x minus 4. So I'll write this off. In the C part, I have here 2x. Instead of x, I have 2x. So it's already no for this. And let's look at D. Let's look at D. So in our D, I have here x here, I have here x minus 4, I have here x plus 2. And that's what I have here. So this is my correct answer. So even without solving, I've been able to get the answer to this.